all the problems that we're going to do in this morning's workshop, you could do with a for loop, right? And I think in some ways that was kind of where a lot of you got tripped up was you had a global variable that you're basically just modifying through a for loop, right? So it was kind of this hybrid approach. But I guess the important part is that at least like it wasn't a straight iterative approach, but you probably weren't also kind of embracing recursion to its full abilities. And so we talked about how a lot of the problems could be done with a for loop. But I also mentioned the reason why recursion does exist and the reason why it is a useful kind of pattern to know is because there are some problems that you can't do without recursion, or rather, there are some problems that you cannot do with a typical for loop, right? So if I took some of the solutions from this morning, where we had a global variable and we were using a for loop, that might fail, right? Or the solution that you have may not cover all edge cases. And so for this afternoon session, we're going to talk a lot about, or we're going to talk a little bit about kind of, in what cases does recursion kind of become the main way to solve the problem, or maybe the only way to solve the problem. And the short answer is nesting. We talk a lot about nesting. We talked about arrays. We talked about objects, and we mentioned how we can infinitely loop, or rather, we can infinitely nest an array in one another. We can have an object that infinitely has infinite objects being nested within each key value pair, etc., etc. And so the power of recursion really comes through not when we know we need to do something like 10 times. Like if I was to calculate 10 factorial, right? I know that I'm going to need to do 10 mathematical operations. And at that point, a for loop or a recursion, either one could probably get the job done. But recursion really shines when we come across a scenario in which we have no idea how many times we need to do something, right? So let's say I give you in the first in this example here under crazy array, let's say I give you that thing there, right? It's an array, clearly, but each element could either be a number or it could be another array. And then within that, each element could be a number or in an array, and so on and so forth. And really, at the end of the day, we actually have no idea how many nestings that array could possibly have, right? I could give you an array with 10 times that many nestings, and it's still an array. But if I asked you to do something with it, you would probably come across a scenario in which you would say, okay, if I know there's one layer of nesting, I can do a for loop and I can do an if else check, right? If I know there's two level of nesting, I might be able to do another for loop, another if else check. But if there's infinite numbers, potentially infinite numbers of nesting going on, then at some point you're not going to be able to write infinite numbers of for loops, right? Something has to give. And so recursion, kind of like a while loop, recursion is great for use cases where you don't exactly know where your endpoint is, but you know that you'll eventually reach it. So in that way, it's similar to somewhat of a, it's very similar to a while loop, except recursion can let you do probably a little bit more in terms of like the overall logic, the overall of how you handle things. So let's talk about a function that we want, right? That I feed it an array, and the goal here is to say, well, hey, this array, could have numbers, but it can also have other arrays. Now, the good news is I can kind of make the assumption that it will only have either numbers or arrays, but I have no idea how deep the array could go, right? I could have an array inside of an array inside of an array inside of an array, so on and so forth. But the point of this function to say is, hey, do you mind printing out for me every single number in this array, right? So if I have an array that's 6 levels deep, well, my function needs to be able to go in 6 levels deep, find that number, and give it back to me, or at least print it out in this case. So how do we do that? Now, if an array was simply one level deep, this simple for loop does a job, right? And we've seen this plenty of times. But if I have something that has one level of nesting here on line 8 there, where the 2 and 3 is in its own array, and we want to list every number inside of it, it becomes a little bit tricky, right? Because when I log out each element, it's going to log out just the number if it's a number, but if it's an array, it's not going to log out for me every single thing in the array. It'll just log out the entire array as one thing. Now, this solution we've seen before, clearly, right? This is the one I think we implemented when we first started talking about, I think, for loops or maybe arrays, where we say, okay, let's go inside this array. For every element, let's check. If it's an array, we'll call this function again. Or if it's not, we're gonna log out the number. Sorry, that was a terrible explanation. So here we've seen this before, right? This array.isArray to check if something is an array. And before, what we were doing is we wrote another for loop where line 6 is, and we're saying, hey, if this thing is an array, let's write another for loop. Let's go inside that array and let's print everything out, right? Implicit there was an assumption we had that if it was an array, it was only going to go one level deep. Well, now when we step back and we look at our function, we already have a function whose entire job it is to loop through the array, right? To loop through everything in an array, check to see that element is an array or not. And if the nesting is only one level deep, then what we're going to do is we're just going to print it out. So in this case, what's our base case for this function here? Anyone? Andre?
When it's not an array, it's gonna, by the time you get to the bottom point where it's not an array, it'll just console log out.
Yeah, exactly. So to understand kind of where the recursion happens, yes, we have a for loop here, but within the for loop, like nothing inherently in the for loop, if we remove lines 5 through 10, is calling this logs and array function recursively, right? The only place where we call logs and array recursively is here on line 6, and we only do that if line 5's if condition is being met. So if we know we have one condition in which we're going to call it recursively, then the opposite of that, in this case, the else statement, must be when we stop, right? So when do we call this function recursively? We call it when the element is an array. So therefore, our base case is whenever the element is not an array, we stop, right? If this is false, if array.isArray is not true, then we never hit this and we just console log and hey, we're done. So if we look at the call stack for how this function is going to work, then assuming we give it that array input at the bottom there, the first thing we're going to do is we're going to log say, hey, let's log an array and let's feed it, the input that we had already seen it. And when we go through this array, the first element that we're going to go through at index 0 is going to be a number. So we just console log out line 9, right? We log out the element. Sorry. When we look at the first element of this array here, the first element is just a number. So when it goes through, it'll say let element equals array index of 0, which is just number 1. And it'll say is 1 an array? It's not an array. So we're in the else statement. So we're going to console log out this 1. And that's pretty good, right? Nothing crazy so far. In fact, we haven't used any recursion yet, right? Right now we're just going through a for loop like we would normally any other array. But when we look at the second element here, let element equals array index of 1, we have this other array. And so is this array an array? It is. So we're going to feed that array of 2, 3 into logs an array, and we're going to call logs an array again, which is why we're here, right? Remember, the reason why this goes on top of this function is because logs an array of this cannot finish until this finishes, right? It has to happen in a very specific order. So now we're looking at this, where there's logs an array, and we feed an array with 2 numbers. So let's see what happens when we feed an array of 2 numbers into logs an array function, right? We're going to go through it. So when I is 0, element index 0 is going to be 2. Is 2 an array? No, it's not. We're going to console log out just the 2. Okay, so far so good. Next up, let's go to the next element of the array, a 3, right? If let element equals array index at 1, element is just number 3, is 3 an array? The answer is no. Great, let's console log out just 3. And at this point, we're done with this function, right? There's nothing else to go through. We've gone through the first element and logged it out. We've gone through the second element and logged it out. And as far as I'm concerned, this for loop is going to be done, right? I++ can give us 2. Is 2 less than 2? No, it's not. So this for loop is done, and there's no other code to write. So once we log out the 3, we're done with this particular part of the call stack. We take it off of our to-do list. We take it off of our stack, and then we go back here and say, all right, now, where were we, right? Where we were was trying to figure out what to do here for index for the array at index 1, and we did. So this if-else statement also finishes, and then I look up here and say, okay, great. What's I++ now? It's 2, right? This was the 0th index. This was the first index. I've just resolved this. So it's 1++, which is 2. And then now I'm asking, is 2 less than 2? No, it's not. So this for loop finishes, and I can also finish out this logs and array. Okay, that seems a bit simple, or rather, that seems a bit simple, and we probably could do this for a much more lengthy example. But notice how the way that this function has been set up is this. If this 3 was an array, what would happen? Well, oh shoot. Okay, if this 3 was an array instead of just a number, what will happen on this call stack?
You have log an array of that array.
Exactly. If this was an array, we would go through here. We would say, okay, is this element an array or not? And the answer is not. Then we log it out. But if it is, we'll just call logs an array again, right? With an array with a single value of 3 in it. And so, if we if you think about the way that this function is really working, is we can have infinite levels of nesting, right? And it's fine because our function will just build up infinite levels of recursive calling to get to the bottom of the array. I say infinite because we could say that well, technically speaking, I guess the computer could run out of memory before we finish nesting it, but it's kind of like very unlikely, right? So we say like this is a solution to solving an infinitely nested array problem, right? Like if we're getting to a level in which the computer can't handle the processing, it's probably a different question what we're doing. But conceptually, at least, this function logically can handle as many layers of nesting as possible, right? Before I don't have to know how deep this array goes, right? My function is built to handle infinite levels because it'll just keep checking at every successive term. So this is something that we actually would not be able to build using only a for loop, right? With the for loop, we would need to keep writing if-else's and nesting that, keep writing if-else's and nesting that. But at some point, if we write 15 layers of if-else's, well, there could be 16 layers of nesting and our function falls flat, right? So this is something, because there's an unknown element, we actually need to use recursion, because the idea of recursion is, hey, let's just keep going until we reach our base case, even if I don't know when that base case is as long as I know that that base case will be reached imminently. Okay, so let me just go to the function. Okay, so this function is actually very similar to the previous one, right? The idea here is that we feed it an array of not just things we print out now, but now what we're doing is we're feeding it an array of either letters or arrays, but now we're actually trying to join all of the letters together, right? We're not just going there, throwing a simple console log and saying, great, let's move on. Now we actually need to keep track of the elements that we're seeing as we go deeper and deeper into the array, right? It's no longer just like a print it out and forget about it. It's like, well, if I'm going to join A to B to C, I need to know B to C needs to add to the end of A. So what that means is if we just feed it a very, very simple array here of just letters, well, this solution works perfectly fine, right? There's no recursion here, right? I only see concat else called once. No recursion. I have a final string, which is an empty string. I go through every element in this array, and I just add the letter to the final string, and I return the final string, right? This will go through, and if the array has no nesting, then I am able to cram all the letters together into a single string. However, what if there is nesting, right? What if we see something like we saw in the last project? Now let's take a look at this code as we have it written here with the helpful call stack. Kind of blocked it, but you guys get the point, right? That's A and then array B comma C. Okay, so the first time we call the call stack, we feed that into it. And by the way, final string. You notice how in this case, or rather, so this is something that's a little bit it's more of a nuanced to what I said earlier. Notice how they have a final string and they're changing it and they're giving it back, right? But notice how when they do it, what they're doing is, as we step through it, you'll see, what they're doing it is, they're not just saying, hey, multiply this, multiply by this, and let's give it back at the very end. What they're doing is they're actually recursively calling it so that each time we call it, it's not like these are all changing different versions of final string. A little bit confusing, but when I step through the code, hopefully you'll see what I mean, right? But let's just say for now, concat else, right? When we feed it in the first master input here, final string at the beginning is just an empty string, right? After line 2, we then go through it and we say, okay, let's go through the array that you just fed me. The first element, letter A, right? Element is equal to the letter A. Is A an array? No. We are in our else clause, and then we say final string is just equal to plus or equal the A. So now our letter is going to be, or now our final string is just the letter A, right? Cool. Next up, when we go to the second element, we have it to we're telling it, okay, what's the second element? Oh, it says array B comma C. So element is the array B comma C. Is that array an array? It is an array. So we need to run this now. Final string, which is the letter A, and then we're adding concat else the array B comma C to it. Well, at this point, I actually don't know what this is, so I need to figure out what that is before I can move on with my code, right? And so now I add another recursive call of concat else to the call stack. When I call concat else to the call stack, notice how concat else also has its own version of final string, right? Because I'm not modifying the final string from this concat else, right? I have my own concat else for this call, right? See left? I'm defining a new version of final string each time I call this function, okay? So my new version of final string, at the very beginning, it's going to be empty. And then when I go through this array of B comma C, as I go through it, I'm going to add my own thing to it, right? So when I go through the first element, I'm going to add a B to it, so it becomes just B. And then when I go to my second element, I'm going to add the letter C to it. I now get BC. And at this point, I'm done with my for loop, but my function isn't done yet, because on line 11, I still need to return final string, right, which is the letter B and C. So if concat else B and C equals BC, I can replace BC with this here. And then when I return this on line 11, I get back ABC. Okay. The distinction between this and what I saw some groups doing this morning was, what some groups had was, oh, I have this final string, and let's just have everyone edit the same copy of final string. Like we'll all just keep shoving our own letters to the end of it. But this is different because in this case, each recursive loop has its own version of final string, and it's only responsible for editing whatever it has at that moment when you call it, right? It doesn't care what work was done, what work was being done before. It just says, hey, I'm gonna start from scratch. I'm gonna do the things that you gave me, and then once I'm done with my part, I give it back to you. I don't care what you had done before. I don't care what you're using it for. Here's in a very shallow way. Here's what I was using. Here's what I've been doing, right? Okay. So using this, we get concat else. But notice, just like before, this function is also very well provisioned to handle infinite levels of nesting, right? Because every time we go one level deeper, what do? The first thing we do there on line 10, we create another version of final string for just that layer of depth, right? We collect everything we could at that level, and then we give it back. We don't care about what work was done before, right? We start from scratch every time on line 2 there. Okay. Okay. Any questions here? Everyone's good? All right. So, so that was us going through nested arrays. And we won't go through, I don't think we have an example here of a nested object, but just know that, well, with an array, we just go through every single thing. We check if that thing is an array, right? With an object, we have a function that we learned, right? Or, sorry, not a function, it's not an operator, I forgot what it's called. But anywho, we have a for in loop that we learned about, right? That goes through everything in the object. So whereas before for an array, we just check to see if every value is an array. Here, we'll just check to see if every value is an object, right? And so if I was to do what I just did with an object, the code would actually look remarkably simpler, right? Or remarkably similar, because the concepts are the same, right? Goes through every single thing, every single value. If it's an array, do this. If it's an object, do this, right? And this is the same thing every single time. So we're going to get some more practice with nested objects, but for now, just know that, if you understand how the arrays work, if you really just like swap out the for loop with the for in loop, we have like almost identical code. Oh, actually, I lied. We are going to do an example with an object. Okay. Okay. So here I have an object. It has two key value pairs, A and B, with their respective values of 10 and 20. Okay. If I ask you, hey, do you mind adding up for me every single number, every single value here into a total? Well, if there's no nesting, so to speak, let's just use a for loop, right? We have a sum equals 0. We go into every single value, and then we just add the value to the sum and return sum on line 9, right? Pretty straightforward. This is us traversing through the object, assuming there's no nesting. However, if there is nesting, okay, I lied. We are going to do this more depth. If there is nesting, well, like quite honestly, doesn't this look almost identical to what we just had earlier, right? Instead of an array that is array, we have type of value equals object, right? Same thing. That's checking something is an array. Here we're checking something is a value, and literally everything else is the same almost, right? Instead of an empty string, we have an empty sum at the beginning. We go through every key value pair in the object, and we're saying, hey, for this key, this is the value. If the value is an object, let's recursively call ourselves. If it's not an object, or rather, if the value is not an object, we're going to assume it's a number, and we'll just add it to the sum. And then once we go through everything, we're going to return the sum. So when we step through this code, assuming that's our input there, so there we have, I think, 3 levels of nesting. In the first level, the first value is just a 1, so we just add that to our total. 1, we're pretty happy. The next one is going to be, hey, do you mind adding your total to this massively nested object? It's like, and at this point, the function just says, cool, yeah, I don't know how to do that. I'll let the next iteration figure it out. So the next iteration gets called, and the next iteration, once again, has their own value of sum, right? We start at 0. This value of sum does not care at all about what the previous value was. It's saying, all I care about is from this point going forward what my sum is. 0 plus, oh boy, immediately my first thing is going to be another really heavily nested object. Once again, I don't care. I'll let the next iteration loop figure it out. And so we actually keep doing this on and on until we get to this point here, and we're like, oh, okay, let's see what this particular function equals. Well, here we're passing it an object, and look at that. There's no levels of nesting anymore, right? Every value is just a number. So if we go to the first value, it's a 2. Let's add 2 to my 0. And then the next one's a 3. Let's add 3 to my 2. I have a 5. So at this point, I'm done with iterating through that object. My sum is 5, and I can return on line 11, 5. Basically, this is going to become 5. So this becomes 5, right? So 0 plus 5 is 5. Oh, great, 5. And so if this becomes 5, then this also becomes 5. So I just substitute the values back. Once again, right, I'm returning the number. So basically, whoever called me, I'm just saying, hey, replace what you had before with what I'm going to return to you now, right? So I had this really complicated, nasty thing before, and now I'm saying is, hey, I'm going to return 5. So I can just slot in 5 to wherever that used to be. And so back here, I'm finally back. I've kind of solved through all the layers of problem. I finally have finished going through the object, and my sum is 6. So I just return a 6, and I'm happy. Right? This is almost identical to the array problem. We just have a different check for whether or not something is an array versus something is an object. And now we're adding numbers instead of adding strings. Any questions? Okay, great. So